welcome back to the next session of the control system. In the previous lecture we have seen what is the difference between a system and a control system. Then we moved to the types of the system, which are basically open loop system and closed loop system. So I told you that an open loop system is a system which do not have any provision to select the reference input, and on the other hand our closed loop system is a system which have some provision to select our reference input. Then we moved to the transfer function, which is basically a mathematical model of any system. So a transfer function of a system is defined as the Laplace transform of the output upon the Laplace transform of the input, with an assumption that our initial conditions are 0. So let us move further. There is one more definition of the transfer function. So a transfer function of an LTI system is defined as the Laplace transform of the impulse response. The transfer function is also defined as the Laplace transform of the impulse response. See, I have a system in which I am giving the impulse signal. The output is called as impulse response. So the transfer function is defined as the Laplace transform of impulse response upon the Laplace transform of impulse signal. So what is the Laplace transform of impulse signal? That is equals to 1. So our transfer function is defined as the Laplace transform of impulse response. Consider this system. I am assumed that the value of the system is 1 upon s plus 2, and I am giving the impulse signal at the input side, and output side I am getting the impulse response. I am denoting this input by Rs and our output by Cs. So the transfer function of this system is equal to Cs by Rs, which is equals to 1 upon s plus 2. So if I am considering at the input side impulse signal, so the Laplace transform of RT, which is equal to Laplace transform of impulse signal, that is 1. So Cs will become 1 upon s plus 2 into 1, that is again equal to 1 upon s plus 2. Now I am taking the inverse Laplace transform at both sides. This results in Ct equals to e power minus 2t into ut. See, the output contains only system terms. So we can say that the impulse response represents the system characteristic or the behavior of the system. Here the behavior of the system is exponentially decay. So the impulse response represents the system characteristic or the behavior of the system. It is also called the natural response of the system. But if I am giving any other signal instead of impulse signal, the response is called the forced response. See this question. The impulse response of an initially relaxed linear system is e to the power minus 2t into ut. The impulse response is given, that is e to the power minus 2t into ut. To produce a response of t into e to the power minus 2t, the input must be to produce a response of t e to the power minus t into ut. They are asking the value of Rs. So I told you that the Laplace transform of the impulse response is our transfer function. So Laplace transform of impulse response is our transfer function, which is equal to 1 upon s plus 2. So this Laplace transform of impulse response equals to transfer function, which is equal to Cs by Rs s plus 2. Just by substituting the value of Cs from here Cs is 1 upon s plus 2 whole square into 1 by Rs, is 1 by s plus 2. So this one cancelled. 1 by Rs is equal to 1 upon, it is s plus 2. Rs is 1 by s plus 2 and Rt is e to the power minus 2t into ut. Here I am applying only that simple concept that the Laplace transform of our impulse response, that equals to the transfer function. Okay. Now we will see the transfer function of the open loop system and the closed loop system. I already told you the main components of the open loop systems, which are controllers and process. I am combining these two blocks as GS. So this is our input Rs, this is our output Cs, and the transfer function of open loop control system is Cs by Rs, which is equals to Gs. Similarly, how can I represent the closed loop system? I am combining the controller and the process as Gs, this is our Rs, this is our Cs, and I am representing my feedback signal as H of S. Okay? This feedback may be positive or it may be negative. So remember this, the transfer function of this closed loop control system is given by Gs upon one plus minus Gs into Hs. Here we will consider plus sign for negative feedback and minus sign for positive feedback.